Hello. I've been given another project. This one's a fairly big project. It's pretty time sensitive. I have to do it fairly quickly. And it's to build an auger bore machine. Now, an auger bore machine is a method of installing pipes in the ground, and the specific application for this one is to install culverts under roads. And sort of drawn a section of a road here, bit of an ugly car on the top, and they're trying to put this pipe across the road for a culvert. It's a method of installing pipes without having to open cut or just dig a trench across the highway, which is disruptive and damages the road bed, and then it has to be patched, and it often the ground often sinks after you do it, and then you get dips where the culvert was installed. So this is a really good method of installing culverts under highways. There's different ways of installing the culverts. This particular one is what's known as auger boring. And essentially what you do is you set up a frame here, skid, I guess you'd call it, up against a thrust block, and then you have a pushing unit which rides on the skid and can lock to it, and then it can apply a large amount of force. In our case, we're looking at about 200 tons. It can push, and that will essentially push the pipe through the mud in the roadbed. It's just a brute force thing. You just push the pipe through, and then the pipe acts like a cookie cutter, I guess, a very tall cookie cutter, and the dough is very thick, and it essentially, the leading edge of the pipe cuts the mud, and the mud goes into the pipe, and that mud has to be removed. Eventually what will happen is it'll just get so hard to push with the mud inside that you won't be able to go, and you have to remove that mud. And with the auger bore method, what you do is you put a full length auger in. So these squiggly lines are supposed to be the flights of the auger, and you rotate that as you're advancing in, and the leading edge of the auger is constantly chewing away at the plug of mud that's coming into the pipe, and then it carries it back, and it just gets shot out the side of the machine where a excavator can remove it. You can buy these machines complete, but my customer has he has some tunnel boring machines and guided boring machines for doing this kind of work. They're generally used for larger sizes of pipe, and he has pretty much all the components required to make an auger bore: the skid and the pusher unit, and he has what I've got listed there is an auger motor. He has a motor that'll work, and it can be run by the pusher unit. The pusher unit has a power pack in it to run the hydraulic cylinder that provides the pushing force, and also a hydraulic circuit to run a motor. So we'll be able to tap into that. So he has all these components, except right in here, this is a frame that I'm being asked to design and build, and essentially it'll hold the auger motor, and it'll transfer the force. This is supposed to be a hydraulic cylinder here. It'll transfer that force through the frame to the pipe, and some of the force will be transferred to the auger motor, which then pushes on the auger to keep advancing it into the plug of mud. They have all the components except this frame here. So that's what I have to design. They would like to install their first culvert in about 6 weeks, so it's a pretty short timeline to design, come up with drawings, order material, and then build the damn thing. But I think we can do it. The first thing that has so far shown up in my shop is the auger motor, and today my father-in-law is helping me with this job. He's gonna take off some of the components of it that we don't need. The auger motor is a screw pile anchor installing motor, essentially. Normally it's attached to the end of an excavator, and it's used to rotate and push helical screw piles into the ground. And that that's right here. All this from the pin to the right, we're going to remove. We don't need that for this job. And this essentially consists of, from here to here is just a rolled can. See, and inside of there is a hydraulic motor. And then inside of this area here is a set of planetary gears that are just a reduction gearbox. And then out the end is a square shaft. It's 5 1/4 inches square. And this motor is capable of 95,000 foot-pounds of torque. So it'll have more than enough torque to drive this auger. And you can push on the shaft with a force of about 95,000 pounds. And you can pull back on the shaft with a force of about 50,000 pounds. And although this is going to be attached to a frame that can push with 400,000 pounds of force, this motor should never see anywhere near that. It only has to advance the auger into the mud. So we're going to strip this down and I can get some measurements off it. I have to design and build a cradle that'll go around the planetary gearbox to stabilize that in. And then I'm going to have to make some bosses here for the pin to go through, one on each side. And that'll have to be attached to some type of a frame. And then that'll mount on the skid and be pushed. It's going to require obviously some fabricating and welding. That's where my father-in-law come in. He's the welder. And there'll be some machining. I'm going to make the bosses. I have to make a pin. I likely will have to machine the cradle out. I'm going to try and design it such that I can bore it out on my large lathe. I'm going to have to take advantage of the gap. I can swing about 45 inches in that gap. So I'm going to try and design it so that I can actually swing it in there and bore it out. Yeah, so that's the project in a nutshell. I'm hoping I'll have time to take some video of it as I'm making the stuff. But it's a pretty tight timeline, so I'll have to see. Maybe in the end I'll have some video of it actually installing a culvert.